Hi everyone. Welcome back to Study Sprint. Today, we're going to explore ionic bonding, a super important topic for your GCSE chemistry exams. So let's jump right in. By the end of this video, you should be able to describe what is ionic bonding, explain how atoms form positive and negative ions, and recognize properties of ionic compounds. Ionic bonding happens when a metal atom transfers electrons to a nonmetal atom. But why does this happen? Well, atoms want to be stable, and they achieve this by having a full outer shell of electrons. Metals can be found in the middle and on the left-hand side of the periodic table. Nonmetals can be found on the right-hand side of the periodic table. Let's take an example of sodium, which is a metal. Its electronic configuration is 2, 8, 1, so it has one electron in its outermost shell. Now, sodium wants to be stable, and to do that, it needs to have a full outer electron shell. So, what does it do? It loses that one outermost electron. By losing an electron, sodium becomes a positive ion because it now has more protons than electrons. Take an example of chlorine, which is a nonmetal. Chlorine has 7 electrons in its outer shell, and to attain stability it wants to have 8 electrons. When chlorine gains an electron, it becomes a negative ion, because now it has more electrons than protons. Now it has full outer shell of electrons. So ionic bond is formed when a metal and nonmetal react together. Metal atoms become positively charged ions by losing electrons, and nonmetal atoms become negatively charged ions by gaining electrons. Now these oppositely charged ions are very strongly attracted to each other with an electrostatic force of attraction, and they form ionic compound. Let's go back to our example of sodium chloride. Sodium is a metal with 1 electron in its outer shell, and chlorine is a nonmetal with 7 electrons in its outer shell. Sodium gives its 1 electron to chlorine, so both atoms end up with full outer shells. After the transfer of electron, sodium becomes a positively charged ion and chlorine becomes a negatively charged ion. These oppositely charged ions are strongly attracted to each other, forming an ionic bond and creating sodium chloride, or table salt. Ionic compounds don't just form simple pairs of ions, they create a giant ionic lattice. This is a regular, repeating structure where each positive ion is surrounded by negative ions, and each negative ion is surrounded by positive ions. Due to this structure, ionic compounds are usually solid at room temperature and have high melting and boiling points. It takes a lot of energy to break all those strong ionic bonds. So as the ionic bonds are really strong, and require lots of energy to break them, ionic compounds have high melting and boiling points. Secondly, ionic compounds can conduct electricity when they're dissolved in water or melted. This is because the ions are free to move and carry charge. But in their solid state, they can't conduct electricity because the ions are fixed in place. Before ending today's lesson, I want to share a tip with you all. For elements in groups 1, 2, and 3 of the periodic table, the number of electrons lost is the same as the group number. For example, magnesium is in group 2, so it loses 2 electrons and forms a positive 2 ion. Whereas, for elements in groups 6 and 7, the number of electrons gained is 8 subtract by the group number. For example, oxygen is in group 6, so if you subtract 6 from 8 you get 2. Therefore, group 6 elements gain 2 electrons and form negative 2 ions. And that's it for today's video on ionic bonding. If you found this helpful, don't forget to give it a thumbs up, subscribe and hit the bell icon so you never miss a video. Thanks for watching, and I'll see you next time.